I'm going to welcome Antonello. Hello, Antonello.
Hello, hi everyone. Hi
How are
Scoop.
you?
I'm fine. You?
I'm good. I had a nice lunch and I did a nice walk around the area here to stretch my legs, get a bit of
Nice.
fresh air.
Yeah, exactly.
So you are Italian,
Yes, I am.
but I read that you actually live in the Netherlands.
Yeah, I do. I live in Rotterdam, so yeah, it's been 2 years, so quite not Dutch, but almost entering in the Dutch culture.
So I can now start speaking Dutch to you.
Okay, that will be a problem. No, Dutch is
Okay,
so hard for me. So
let's keep it in English because
yeah.
everyone else wants to hear what we're talking about anyway. You're interested in things like DDD, continuous deployment, test-driven development, things like that. These
hmm
are all the best practices that people are supposed to be using by
hmm
now, right? Or maybe not everyone.
No, well, I think everyone, starting from project of a certain complexity, I would say,
Right.
those are practices that should be followed. For simple projects, probably some of them are overkill. I would say.
Yeah. Yeah. Okay. I also hear that you like football.
Yeah, I do a lot.
Yeah. Is that Italian football or Dutch football?
No, I also love Dutch football. I'm studying the history of Dutch football starting from the 70s, so I'm quite passionate about it. But also, yeah, of course, I follow Italian football and yeah, European football in general.
Yeah, okay. So let's dive into your talk. What are
Okay.
you going to talk about?
Well, continuous delivery basically. So code
Okay.
test, deploy, repeat.
Yeah, yeah. Well, that's what the title says. Okay,
Yeah.
I'll give you the stage. Have fun.
Thank you. So, code test, deploy, repeat is the mantra of developers working in a continuous delivery with a continuous delivery approach on a continuous delivery project. So let's start from the definition of these of the wording of all these buzzwords. Well, continuous integration is the practice where developers merge their changes back to the master branch as often as possible, and running, of course, tests, automated tests to validate those changes. While continuous delivery is the practice in which the deployment to production after the validation of the CI is fully automated, so it can be triggered by just pushing a button or something like that. Continuous deployment happens when, after the CI validation, the deployment to production environment is triggered automatically. So as I mentioned, I'm Antonello. I live in the Netherlands since a couple of years, and I'm a software engineer and Scrum Master. I work for VONQ, which is, just to give you a bit of a context, a company that basically helps other companies to find the right talent for their job vacancies. So we have a platform with which we serve a lot of different services related all to job marketing, basically. Is written mostly in PHP, but we have some services in Python and Scala for, let's say, the data-related things. And I'm gonna try to tell you our approach and our journey to continuous delivery. Let's start with the first word of the title, which is code. How do we code in a continuous delivery with a continuous delivery in mind? Well, we do fast and tiny PRs, which means just ship your code. So in a way, just move your code out of your machine very soon and keep the PR, the pull requests very, very small, very readable, very reviewable. And that's why we do also a lot of code reviews. It's quite a big part, well, not a big, but a decent part of our daily routine, code reviews. I've been doing code reviews while I was watching the previous talks, for example, in the meanwhile. Pair programming. Pair programming is another way, together with code reviews, with which we can share the knowledge and reduce the risk of the code that we bring in production. So those three techniques, approaches, whatever we want to call it, are useful to lower the risk of each deployment. But of course, deploying in production also maybe incomplete features just to keep DPR small. Then we need a specific tool, which is feature toggles. Feature toggles are also called sometimes feature flags. It's basically a technique for adding a functionality in such a way that it can be turned on and off very easily. And it basically allows developers and product managers, for example, to integrate code in the master branch very often. That is the very definition of continuous integration. To change the system behavior without changing the code itself, and other stuff more related to the product point of view. So A/B testing, experimenting features, doing partial releases. We'll get to that later on in this talk. What a feature toggle looks like in the code? Well, it could be something like this. So let's say that we have a new functionality that we want to bring to the users, and we still have the old functionality in the code, and we want to keep them both because we want to measure maybe the performance of the functionality of the new one, or maybe the new one it's still incomplete, and therefore we use this kind of trick. So if the toggle is on, then I show the new functionality. If the toggle is off, then I show the old one. Of course, this brings complexity to our code, if-else. So there's an entire movement against the usage of if-else. And but later on in the talk, we'll understand how we can manage this complexity. How can we keep this technical debt in a manageable state? But first, let's try to define what kind of feature toggles are out there. What kind of types of feature toggles. I stole this diagram and also this definition from an article by Martin Fowler. It's incredibly beautiful article on the topic. Well, there are four main kind of toggles. So the release toggles, which are the ones that I basically already mentioned. They allow incomplete features to be integrated into the master branch and turned on only when the feature is complete, or maybe when the product manager decides to. And it basically implements the concept of separating release from deployment. They should have a short life, as you can see from the diagram, and also they could be also not very dynamic. They can change on the deployment stage, for example. There are also experiment toggles, very similar, but they are used in a way that you put your users, the user of your system, in different groups, and you decide what to show to each group. So, for example, you might want to show your new functionality to a specific group of users and the old functionality to the other group of users and measure the performances. They also should have a short life, so the life of the experiment, basically. But they are dynamic because they change based on the information that the user provides. So based on the user that is logged in that moment, for example. So they are very dynamic. Then there are ops toggles that are mostly related to operational aspects of the system. For example, if you want to measure a performance of a specific functionality before you roll it out to all the users, or for example, you might have a toggle on a specific functionality that is very slow, or you think is very slow, very demanding, and then you might want to turn it off in specific moments. And that's why, for example, they can have a long life actually in the code. And then there are permission toggles that I wouldn't suggest to use because they are basically for showing a set of premium features to a specific premium group of users. But I mean, there are other techniques to do that, so I wouldn't use permission toggles. But well, they were in the article, so I just mentioned that. those. What you can do to keep the technical depth and the complexity of the code in a manageable state? Well, for sure you have to decouple the point in which the toggle is evaluated from the point in which the toggle is defined. That is, you have to centralize the logic of all the toggles. So you might want to have a toggle manager to which you ask the status of a specific toggle. You might want to try to avoid conditionals, as I mentioned before, using patterns or whatever you can to avoid if a bunch of if-else in the code, basically. And then the most important one is remove toggles. They have a lifetime, as we saw in the previous slide. So as soon as you finish your experiment, as soon as the feature is complete, just remove the toggle and remove the old code related to the old feature or the old version of the code if you have. In that way you keep your code clean and you keep it in a manageable state, as I said before. They might have, well, they for sure have two statuses, active and inactive, but they might have also a third state that is the conditionally active. And the condition can be, as I mentioned, the state, the user, for example, or the company of a specific user, or a specific field or characteristic of a specific user. In that way, we can do really A/B testing, experimenting a new feature and stuff like that. So it's the most interesting state, I would say, of toggles. In VONQ, we use a library that was developed internally a few years ago. It's still active, but it's still working. We use it in production every day. Is one of the most used probably in the PHP world, but there are many others. So and also in other languages, there are a lot of them. So you can use this technique in pretty much every language, I think and I hope. In this case, we have three different adapters, so we can store the status of the toggle in memory, in a config file, YAML, for example, or in Redis, which is very, very handy. Well, the second step, of course, of the title, but of this flow is testing. So the CI tests your code once you want to, or just before you want to merge it to the master branch. So I'm going to show you the most famous pyramid in the world of software engineering, but it's not this one, of course. It's not even this, and this one is Rome. So because we actually have a pyramid in Rome, and this slide makes me homesick a little bit, or Rome sick, if you want. And not this one, which is, by the way, an incredible record from Pink Floyd, but this one. This is the pyramid, the test pyramid. So as you can see, this means that the lower you are in the level of testing, the more tests you should have. So for example, we have a lot of unit tests. We basically unit test everything we write. We use PHP spec, but you can use PHP unit. You can use a lot of other tools that are out there. So really doesn't matter the tool that you use, but just do it. Just write a lot of unit tests. Try to test everything with unit tests because they are fast. So they're not expensive at all. Then we write a bunch of integration tests when we cross the boundaries. So when we interact with an external system, and we want to make sure before we deploy that system behaves in a way that we understand and that we want it to behave. Then we write an integration test that, of course, is also expensive because you do actual calls to the external service or your actual call to your database, for example. And then we have UI tests, very few of them because they are very, very expensive. And we call them acceptance tests. Someone can call them end-to-end tests, but whatever. They are tests that actually hit the UI. So they go through the login page, they go through all the pages, the most important pages in our application. They perform requests on the most important paths and features of our platform. So just to make sure that everything is working, or at least the most important features are working. Well, I mentioned it a lot of times now. Deploy. Well, after you write the code in a proper way, after you test it and your CI is green, you deploy. And well, this sentence basically sums up our philosophy in this. If it hurts, do it more often. It's not something that it's a bit counterintuitive, as in for sure it's not something that doctors will tell you to do, but it works a lot in software engineering because well, I could try to explain with words, but it's actually this slide, this diagram that I stole from Henry Nyberg tells the story better than I do. On the left side, you see the risk. How big is the risk of deploy with a lot of code in it? That can be also, for example, deploying every few weeks or every month, for example. It's a huge risk. While on the right side, you see how can you lower the risk of deploying if you deploying a small chunk of code more frequently, a lot more frequently. Another important thing that we try to follow, another important principle that we try to follow is that everyone can deploy. And of course, not literally everyone in the company, but at least in the engineering team, everyone should deploy. And that means that even though we have a dedicated DevOps team that is basically owning the infrastructure, all the pipelines to production, so all the automation that brings our code to production, we need to be able to deploy independently as developers, as teams. And I think the first thing that I did during my onboarding, the first or the second day, is deploying to production. At the time, the deploy procedure had manual steps, but is one of the first things that I learned because I had to be able to deploy every time I wanted. So that's the philosophy. Of course, you need automation, as I mentioned already, and this is pretty much how we automate our steps. We automated during time our steps to production. So as you can see, there are two main events in our pipelines. The first one is when we push our code, and of course we set up the project from scratch. So we use tools, of course, like Jenkins or Drone lately. And this tool is able to set up the project from scratch. We use Docker, but again, you can use whatever you like. We run some quality checks, static analysis, security checks on dependencies, for example. And if everything is green, if everything goes well, then we run all the test suite except for the UI tests. So we run unit tests, functional tests, integration tests also. And if everything is green, then we know that the PR, that branch that we pushed, is reviewable. And we open a PR, and then, of course, the code review happens. When we want to merge this code, that is, we want to deploy to production this code, deploy, not release, to production, and then the same thing, the same three steps happen. If they are green, we deploy to an environment that we call acceptance, but it's basically a staging environment, a production-like environment, I will call it. And after deploying, if deploy goes well, we run the actual UI tests. So in here I call them acceptance tests. And we run them on a production-like environment. So we are fairly sure that every critical path is working. So we are fairly sure that we can deploy to production safely. And that's what we do. So the last step is deploying to production. Of course, you can add different steps into this pipeline as you need. For example, you might add smoke tests after you deploy to production. So on the production server. So you want to check that everything is working on the production server. And if it doesn't, you might want to have, I don't know, alert or a siren screaming in your office or in your home in this case. Of course, deploying in production so often and in a so automated way, you need to monitor. You need to monitor everything makes sense for you from a technical point of view and from a business point of view, because it's not the business part of your software is also important. It's not just a technical approach, this one. So you might want to monitor error logs, for example. You might want to monitor exit status of scheduled crons or processes that run, whatever makes sense for you, really. External services, for example, if you rely a lot on external services, then you want to monitor them because, for example, if they are slow, you might be slow too. You might serve your application in a slow way if the external services you rely on are slow. You might want to monitor your controllers. If you're exposing APIs, for example, you might want to monitor your controller execution time. And again, everything makes sense for you also from a business point of view. Then there is a fourth step. It's hidden, it's not in the title. I cheated here. But it is just because this is the principle that I already mentioned, actually. So decouple deploy from release, because the act of deploying some code into production isn't necessarily the act of showing the code, the feature, to all the users, which is called actually a release. And that kind of philosophy, that kind of principle lets you have interesting tool to grow your business, basically, like A/B testing. A/B testing is basically dividing your users into groups and show them a specific feature or a specific version of your feature that you want to bring in production, that you want to release to everyone. And then you measure the performances of the feature, and you are able to choose based on data which kind of feature you want to actually release to all the users and which feature maybe you want to just remove from the code and not maintain anymore because it's not worth. So very powerful. A similar technique is canary releases. So you might want to, if it's a critical feature, you might want to release it to only to maybe internal users and measure their appreciation for the feature. Or maybe you want to release to a small part of your external users, and then again measure the performances, measure the happiness of your customers before you release the feature to all the users. So quite powerful, really powerful. This technique, this name, the canary release name, comes from a similar technique, if you want, that coal miners used, or still use, I guess, to release canaries into a mine. And if they came back singing, it means that the mine is safe. If they don't, then it means that you should not enter the mine because there will be probably toxin or toxic gas or something like that. So quite cruel as a name, but still. Okay, what's in it for me? True, because yeah, we saw a lot of techniques, some principles, some tools. Okay, but what's in it for me as a developer? I want to tell you a little bit about what was in it for me when I started working in this kind of with this kind of approach. For sure, it sharpened my DevOps skills because, as I mentioned, we have a DevOps team, a dedicated DevOps team, But still, you want to know how Jenkins or Drone or Docker works in your pipelines, because if your pipelines fail, you want to quickly understand what's happening. So in my case, it sharpened my DevOps skills inevitably, which is, I mean, it was fun for me at least. Well, my favorite one, stress-free deploys. That is, you do not fear to go to production, to merge something to master branch and then go to production, because you do it a lot. So you kind of start having the habit of doing it. And how can I say, the stress just is not there, it's never there, because you deploy a small chunk of code. So if something goes wrong, you know exactly where is the problem most of the time. And so we also deploy on Fridays, but please don't tell this guy, because otherwise I won't be able to speak at the next conference. So please don't. And also please don't tell this guy that we also deploy without knowing it. We use a tool called Dependabot. Dependabot creates PRs when one of your your composer dependency has a new version. And that PR, we decided to auto-merge those PRs. And auto-merging those PRs means that we also auto-deploy to production without knowing it. We feel safe doing that, or, well, safe enough to doing that, because we have tests. So we have different level of tests, and we deploy frequently, so we know that our deployment pipeline is working 99% of the time, at least. So while this can sound really scary on one side, and it is, on the other side it brought a lot of benefits, because we do not really deal with new dependency. We do not check if a new dependency is out there and we need to upgrade and stuff like that. It's very much less time consuming than it was before. Everything is around feedback. So the thing is, you should have the shortest feedback loop that you can, and this kind of techniques helps you in doing that. You have different loops, of course. The shortest one, the inner loop, is the one that the feedback that you get from the CI, so from your tests. The other loop is the feedback that you get from monitoring, for example. So in a way that you know if something goes wrong in production before the users do. And of course, the last one is from the users, because at some point you might have deploying in production so often, you might have feedback so often from the users, from a business perspective, but also from a technical perspective, to understand if your application is working properly. And the thing is, you're gonna fail sooner or later. There's no fail-proof environment in software engineering. The thing is how soon you fail. So the sooner, the better, always. And I was working before joining VONQ. So I was working in a completely different project in Italy. It was again a PHP application. But it was released. It had a release every 4 months. That means that we were going to release every 4 months a 4 months worth of code. So a lot of new features, a lot of code, and we didn't feel safe or happy to release. The stress was a lot, and also the technical challenges were a lot, were energy draining. So, but at the time I thought that having to deploy every 4 months for business reasons, or I don't know, marketing reasons, or whatever were the reasons, you cannot really implement a continuous delivery process, because it's impossible. I thought it was impossible, but I was wrong. I was definitely wrong. I discovered that when I started reading this book. It changed my way to think about continuous delivery, and it's kind of the Bible of continuous delivery. So written by Humble and Farley. So basically, I understood reading this book that the path to continuous delivery is valuable itself, even though you're not really doing continuous delivery at the end of the day. So a quote from an Uruguayan football manager came to mind, Oscar Washington Tabares, when they asked him how he felt after winning a Copa America, the reply was, El camino es la recompensa, which is in Spanish and means basically the journey is the reward. And well, this is getting philosophical, but if you want to keep it very practical, is this. So basically, having a continuous delivery process forces you to have to automate basically everything: build, deploy, test, and release process. It forces you to have a comprehensible and a reliable set of automated tests. It forces you, or it pushes you to have a system tests or UI tests that run against a production-like environment, and therefore it pushes you to have a production-like environment. And that is why, even if you really cannot deploy, if you're not going to deploy multiple times per day to the end users, you should aim to create a process that will let you do so. And thanks. And just to mention, this talk is continuously deployed to production, so you can find it. You can find the GitHub repository and the website. I will post later.
Thank you very much.
Thank you.
I was going to ask, do you also continuously deploy this talk on Friday? But it is Friday, so we already know that.
Exactly. I changed something this morning, so I continues deployed also on Fridays.
Very good, very good. So if anyone has any questions, please post them in the stage chat, because I'm keeping an eye on the stage chat. Until there are any questions from the people watching, let me ask you, how do you convince people that the automated acceptance tests are good enough? Because I go into a lot of businesses, and it's mostly managers and upper level people that don't trust automated tests.
Yeah, good question. Well, it's not a matter of trusting, but it's a matter of starting writing an automated test if there's no automated test, and just have the courage of deploying continuously. And then in that way, you understand if your tests are good, and you understand that you should have good tests. Yeah, it's hard to explain, but it's by example, just doing that and watching the results.
Okay. So it's basically just do it and then ask for permission afterwards.
Exactly. Basically, it's that.
Okay, I have another question. What was the experience with the 4-month release cycle? I go on sick leave for each release.
Yeah, the experience was not that very good. I mean, when the deployments were complex for many different technical reasons, but my fear was more related to the feedback that we didn't have for months. So that was the pain point. So no feedback. I don't know if the system is working except for maybe testing or internal testing or QA testing, but still, it was a complex application. So I wasn't feeling comfortable in deploying every 4 months, but we were forced to. And if I could go back in time, I would change a lot of things, but yeah.
Okay, so before you deploy, before the automated deploy deploys, do you announce your deployments to the business?
No, because we do not necessarily release the feature itself. So when we want to release, then we talk to our product owner, we talk to the business, we understand with the stakeholders. We understand, okay, we are releasing, so be aware, and we flip the toggle.
Right, okay. there is a product owner in the chat that says that he wants to deploy on Fridays, but his developers don't.
Okay,
is there a way for him to convince the developers that they should be able to deploy on Friday?
Yeah, I would say try to explain the benefits of being able to deploy safely on Fridays, and then just take some time to understand what's keeping them from doing that. What's the fear? Maybe they don't have good tests. Maybe they don't have an automated process. Maybe the production environment is I don't know, flaky, or for what reason, and then spend time fixing all those constraints.
Okay. Another question, did you have any issues with the auto deployments triggered by Dependabot?
I was hoping no one will ask this question, but yes, we had. Yeah, of course, we a couple of times we had a dependency, a front-end dependency deployed in production automatically, and we had an outage of a few minutes because the dependency broke the code, and the UI tests were disabled for some reasons, and we didn't catch it. So the monitoring started alarming everyone, and then we fixed the problem, and that's it. But it happens a couple of times max in months and months that we are using this auto merge. So
right. And one thing I learned from this is do not disable your tests.
No, exactly. Never, never, because they were flaky for some reason. So we decided, okay, we disable them for a couple of days until we fix them. But no, don't do that. Don't do that.
Okay. How do you handle constrained upper boundaries? Does Dependabot react to that?
I didn't understand the question about the versioning, the version of.
Well, I'm just repeating the question here.
Okay.
So, yeah, I don't know.
Okay.
Let's let Alessandro maybe clarify the question a bit. So, have you ever had any anxiety for a deployment on a Friday, especially?
No, I will say no. With this kind of approach, no, I never, because I know that I can catch the most important errors, and I can safely deploy, or at least the most important features in the platform are there and working. So not that much, I would say.
Okay. I don't get any. Oh, there we go. So yes, indeed, this is about versions.
Okay.
Let me see. We have a new major version that you don't allow. Dependabot asks for the upgrade. Do you have to handle that manually?
No, you can force Dependabot to, let's say, listen to your composer JSON. So if you're in your composer JSON, you allow only minor or patches for a specific version. You can set the Dependabot to not propose you major versions, for example. And in that case, you can feel, since there shouldn't be breaking changes, you can merge it safely.
Okay. Well, thank you very much, Antonello, for your talk, for answering all the questions.